students were given this question. We are expected to find the point of intersection of these two curves at 0, 0 and 1, 1. Now, y is equal to x squared. If you were to draw this graph, it is going to be a U-shaped parabola. So this is going to be the parabola of y is equal to x squared. Now, if you were to draw this parabola, x is equal to y squared, that is going to be a C-shaped. So definitely there is an intersection here, which we can say it as theta 1, and there is an intersection here, theta 2. Now this intersection occurs at 0, 0. This intersection occurs at 1, 1. You are expected to find the angle between the curves at 1, 1 and angle between the curves at 0, 0. So that is the question. Okay, so foremost, let us start off by consider the first curve, y is equal to x squared. Now, when you differentiate, dy over dx is going to be 2x. Now, at the point, we have got 2 points. So, we need to obtain the two slopes there. So, we would be doing that first. So, from here, let me take m1 to be as 2x. Okay. Now, next step, consider the next curve, which is x is equal to y squared. Now we expected to find dy over dx. Okay, so differentiating the right side, it's going to be 2 times y times dy over dx is equal to 1. If I were to rewrite this, this is going to be dy over dx is equal to 1 over 2y. Now let me take this as m2. So my m2 is 1 over 2y and my m1 is 2x. Now, we are expected to find the angle. So, let theta 1, let me write it down. Let theta 1 be the angle between the curves at 0, 0. So, at 0, 0, theta 1 is the angle. Now, let us find out what happens to my tan theta 1. So tan theta 1 will be equal to m1 negative m2 divided by 1 positive m1 m2. Okay, so I need to substitute m1 and m2 over here, and let us do that now. So this is going to be, substitute the value for m1, that's going to be 2x, negative value for m2, that's going to be 2y. Now divided by 1 positive 2 times x times 1 over 2y. So this is what I've got. Now this is rewritten as 2 times x negative 1 over 2y divided by, the 2's can be cancelled here. So that's going to be 1 positive x over y. Okay, so we have got something like this. Now at x is equal to 0 and y is equal to 0. So obviously this is going to be tan theta 1. Okay. Now, if you were to see here, x is 0, y is 0. Now, if you substitute x is 0 and y is equal to 0, x is 0 and y is equal to 0, you will get a quantity which is undefined. But we don't want that quantity to be undefined. So what are we going to do? We are going to use the concept of limits. So I'm going to rewrite this with the concept of limits as limit x comma y is tending to 0, 0, and I'm going to rewrite this by taking 2y as the LCM. So that's going to be 4 times xy negative 1 divided by y positive x divided by y. Okay. Now this can be further rewritten as equal to 1 over 4 times xy negative y divided by, this is 2y. Okay, so I've got a 2y there. Now when I flip this, I would have y being on the top divided by x positive y. So this is what I would be getting. Okay, now clearly the y's can be cancelled, giving me 4 times xy negative 1 divided by 2 times of x positive y. So I've got a quantity like this. Now this is actually equal to limit, you need to write that, x comma y tending to 0 comma 0. Okay, so how are we going to use this limit concept? So now to use the limit concept, what I'm going to do, I'm going to be taking xy out, and that is going to be 4 negative 1 divided by xy. Okay, divided by, now if I were to take xy out, of course 2 is there. Now this quantity is going to be 1 over y positive 1 over x, okay, with a modulus sign. Clearly when you multiply xy inside, y gets cancelled, you will get x. When you multiply xy for this term, the x and x gets cancelled, you will get y. Now x is tending to 0, okay, and y is tending to 0. Now when x tends to 0, it means 1 over x will tend to infinity. Okay, now before that you can cancel these xy terms and you are left with 1 over xy and 1 over x and 1 over y. So the concept of understanding that you need to get here is, as x goes to 0, or as x is tending to 0, 1 over x will tend to infinity. Similarly, as y tends to 0, 1 over y would tend to infinity. So this means the entire quantity will be tending to infinity. So this entire quantity will tend to infinity. So that is the understanding you need to get there. So we take the net output to be as infinity and thereby settle for tan theta 1 to be equal to infinity. So from here we can clearly write tan theta 1 is equal to tan inverse of infinity, which is equal to pi over 2. So the understanding is, at 0 comma 0, the two curves intersect at 90 degrees. Now coming to the second half, which is theta 2, we are expected to find theta 2, and that would be done in the following way. So tan of theta 2 is equal to m1 minus m2. So that's going to be 2 times x negative 1 over 2y divided by 1 positive of x over y. This is what we have got from the first case. So the only reason that we have not substituted the values in the previous case, for the fact that we know that if we were to substitute it, we would get 0 divided by 0, and that's why we use the concept of limits. But in this case, we are expected to find the angle of intersection at the point 1 comma 1. So that means my x is 1 and my y is 1. So using that, we would clearly settle for the following information. So that's going to be 2 of 1 negative 1 over 2 of 1 divided by 1 positive 1 over 1 modulus. So I'm using the space here. So that's going to be 2 negative 1 over 2 divided by 1 positive 1 is going to be 2. So that's a modulus sign. So that's going to be 4 negative 1 divided by 2 divided by 2. So I can very well rewrite this as 3 over 2. Now this is 2 over 1. When it flips, it's going to be 1 over 2, right? So you don't need modulus because it's already positive. So that's going to be 3 over 4. So therefore theta, so theta 2 is going to be tan inverse of 3 over 4. This is the second intersection. So at theta 2 is equal to tan inverse of 3 over 4. The two curves intersect. Okay, that is the angle of intersection of these two curves at the point 1 comma 1. So this completes the solution to this question.